Everyone, today we are going to discuss the topic of transport layer security. Transport layer security is a security protocol in computer networks. The transport layer security was developed by a global community. It consisted of engineers, researchers, and professional workers. This global community was called Internet Engineering Task Force. The TLS is based on Secure Socket Layer, which was originally created by Netscape Communications in 1994. The first version of TLS was the TLS 1.0, which was based on Socket Secure Layer version 3.0. It contained more secure opportunities. The purpose of TLS is to ensure communication over the network between client and server. It prevents data from being tampered, forged. Some key functions of TLS include encryption, authentication, and data integrity. In encryption, the data is encoded at the client side and decoded at the server side. It prevents data from being accessed. In authentication, the TLS checks for identity of the website or the server using the concept of digital certificates. To maintain data integrity, the TLS includes a message authentication code to detect any data tampering. Some common use cases where TLS is used are during web browsing in HTTP or HTTPS browsers, during email communications in SMTP protocols, IMAPs or POP3 protocols. It is also used in voice over IP and Internet of Things.
So now let's study about the protocols of the TLS. The TLS has two more important protocols. First is the TLS handshake protocol and other one is the TLS record protocol. So let's study about the TLS handshake protocol first. The TLS handshake protocol is initiated by the client side by sending the client hello message to the server side. And this client hello message, it consists of the information like chosen cipher source, chosen TLS version and other information like compression methods. And in response to this client hello message, the server sends its server hello message to the client side, which contains the information of the support chosen TLS version and the chosen cipher source. And after this server hello message is sent, server also sends its digital certificate to the client side, and this certificate consists of the server's public key, and this public key is verified by the client side. And after verification, it will proceed to the further step. And after this, the server also sends a server hello day message, and this message indicates that the server is finished sending the hello related message and is now ready for establishing a secure channel. Now after this phase, the client key exchange takes place. The client side sends the pre-master secret, which is encrypted with the server's public key, to the server side, and both the server and the client, they use this pre-master secret to generate a master secret, which from which the session keys will be derived. And after this, the change secrets message is sent by both the sides, and this message indicates that all the future messages which are going to come will be encrypted using these session keys. And after at last the finished message is sent by both the sides, and this message contains the hash of the entire handshake so far, thereby ensuring that a secure communication channel has been established. Now, the TLS handshake protocol has established the communication channel, but the reliable transmission of data is performed by the TLS record protocol. And the TLS record protocol performs this function in 5 steps. The first one is the fragmentation. In this step, the data provided by the application layer is converted into the memory blocks, each of 16 kilobyte in size. And after the next step is the compression step. This is an optional step. Here, these memory blocks are compressed to reduce the size of the data, and this is generally done for the security reasons. And after this step, MAC step comes. MAC means message authentication code, and this is added with the data to ensure its integrity. The client side will use this MAC code to verify that the correct blocks has been received by it. And then both the data and the MAC code are encrypted together by using the systematic ciphers, and these ciphers has been generated in the TLS handshake protocol already. Now after this step, the transmission step comes. The TCP channel is used for the transmission of this encrypted data towards the other layers of the OSI. Now let's study how it works in the OSI layer. In the OSI model, the TLS protocol works on the top of the transport layer, and it performs the function like encryption, authentication, and the data integrity. It converts a TCP channel into a secure communication channel. And it works in the transport layer, but it provides services to the application layer. The application layer provides the plain text data to the TLS protocol, and in return, it encrypts the data for it and sends it to the other layer for the secure communication.
Good morning, I'm Ritik Ranjan, and I'll be going through the topics of TLS working and its applications. The first slide is about working of TLS. So TLS operates in two critical phases. First, the handshake, where you and your browser and the server negotiate security parameters. They use asymmetric encryption like ECDHE to exchange keys securely, even if someone is eavesdropping. So this is like two spies exchanging a locked briefcase with a secret code inside. Only they have the keys to open it. So once keys are exchanged securely, symmetric encryption takes place, and this is like long unbreakable tunnel of data. So TLS 1.3 actually revolutionized this by reducing the handshake time to 1 RTT or 1 round trip, you can say, and supporting 0 round trip presumption for returning users. After this, I'll be going through the next slide, that is about the applications of TLS. So beyond HTTP, TLS is a backbone of email security, VPNs, IoT devices, and as well as the finance. So talking about the email services is that according to whatever we have is SMTP and IMAP, they uses TLS services to rely on so that your emails should be encrypted end to end. Without TLS, your inbox would be as private as a postcard. So VPN services is like that. Protocols like OpenVPN uses TLS to establish a secure tunnels of data transfer. When you work remotely, TLS ensures your company's data stays invisible to the coffee shop hackers. The third point about is that the IoT services is that smart home gadgets like TLS via MQTT over TLS to prevent attackers from hijacking your thermostat or a baby monitor. The last but not the least of the applications of TLS is that every credit card transaction that we do online uses TLS. And yeah, the last I want to say is that even the voice or the video calls that we have today or the blockchain nodes rely on TLS to prevent tampering. And from your WhatsApp messages to the stock trades, TLS is a silent guardian. It's not just technology, it's trust engineered into every byte. Next time you see that a padlock icon, remember there is an entire cryptographic symphony working to keep you safe. Is everywhere.
Okay, so now I would like to talk about the alternatives and advancement in TLS. Now, first of all, we need to know that TLS is not a most recent or new technology. Before TLS, there was SSL. So we could say that SSL is actually predecessor of TLS. Now, SSL actually stands for Secure Socket Layer. SSL was an amazing technology, but it was depreciated due to its serious vulnerabilities. Basically, it has gone through a serious criminal attack, so that's why SSL need to be depreciated. But because of that, we have TLS today, and the most recent version of TLS is actually TLS 1.3. Now, actually, it was brought up in 2018. TLS 1.3 is actually much faster, more secure, and removes obsolete ciphers. And TLS 1.3 has actually reduced the handshaking time to just 1 round trip, and this is also referred as 1 RTT in short form. The another amazing product which I would like to talk about is Quick. Quick was actually developed by Google. And what Google did was actually it uses TLS 1.3 and it supports HTTP 3. So basically they have combined both of them, which had made the overall browsing more faster and more secure in the transport layer. Okay, so now I would like to talk about the implementations and case studies. Now, the first case study I would like to talk about is Google HTTPS adoption. The goal of the Google was very simple, to make like to drive the website traffic to Gmail, search and ads. And so what Google actually did, what steps did Google take is Google enforced TLS 1.2 for Gmail, search and ads, and they also migrated to TLS 1.3. And one thing which Google did was they improved the SEO ranking for the website which has included TLS. So because of that, it gives a lot of motivation to all the website owners to integrate a layer of security, which makes the overall browsing more secure. Now, of course, the impact of this is there were fewer man-made middle attacks, and of course, Google encouraged this, improved SEO rankings for all the sites which include TLS. The next case study or implementation I would like to discuss is OpenSSL. Now, OpenSSL is a library which help you to identify that the website which you are browsing, does that website actually integrates TLS within them or not. So what you need to actually do is you need to go to a browser and you just need to write this command, and instead of example.com you need to write the website name, and after just hit enter, and after hitting enter you will get to know that the site which you are browsing, does that site contain TLS or not. So yeah, that's the whole presentation from our side, from our group on TLS. Thank you for listening to us patiently, and I hope you liked our presentation. Thank you.